so that we can share this out with folks afterwards. But first and foremost, I just wanted to thank you for taking a little bit of time during your afternoons, potentially evenings, if you're over on the other side of the planet, for spending time with us to go a little bit deeper into Physna and provide a product overview too. The purpose of this, followed up with from us, is following the deep tech showcase that we did about 2 weeks back with Eagle Point and the deep tech team. I think a few of them are on there. Can you wave if you're actually on there? Yep, there you go. To go a little bit deeper into the product and what we're doing and what we're all about. And so I'll just quickly introduce myself as I go through it. So, and I get my computer straightened out. So my name is Bo, and I'll be your host and guide here for the next 35 minutes. And the role that I play within Physna is I'm the head of enterprise marketing. And I'm just really thrilled to speak with a group of people about what we do and why we do it. And just to give you a quick backstory on myself, I've had the great pleasure of being a part of a lot of really awesome and impactful moments within technology over the last 15 years, first starting at Google, then moving into Salesforce. But some of the most instrumental time was actually at Facebook within their connectivity initiatives. And while I was there, you really started to see firsthand how the future of 3D was shaping everything from the way that software is developed to the way that hardware is developed. And I'm not just talking about the metaverse type moments that we see in the news, but also into the hardware space, because most of the projects that I was specifically working on was focused on, it's like, how do you bring fiber connectivity to folks in rural environments? And many of that, it comes with like, what are drones that can actually help line power lines with fiber optics to bring stronger connectivity, in the design principles that came from how you developed that. And so I spent a lot of my time working and spending time with designers and manufacturers and engineers. And what I came to learn from that is that 3D is actually at the heart of all things manufacturing. As a marketer, this is your big truth slide when you sit up in front of people. It's like, what are the things that universally people can tend to agree with? And if you've been building and designing products for quite some time, 3D is at the heart of it. Whether it's from CAD design or how you actually build a physical product, you have to understand the complex geometry of a product in order to bring it to life. The challenge when working with folks and working in the field is that the way that you search and find things in 3D still operates in a 2D way, and that traditional tech searches don't understand the complexity of 3D. And this was the core of what Jay was talking about during the Deep Tech Showcase. And why is that? It's largely, we haven't had the computational ability to get there, but today we're using 2D searches to find 3D models, and we hope that we find what we're looking for. And we're doing that from either the non-technical folks like my side, who's either looking in like not distributed or non-distributed databases, or using like SQL or NoSQL queries against like large data sets. We can do it by finding shapes and attributes of KLM models in PLM. And it's like, that's another pretty decent way of doing it. And the biggest thing here is it's like bill of materials. That becomes the crux of what you do. And that's where Physna really comes into play, is it's like we remove the nuances of some of these things by truly understanding what an object geometry is. And if I'm talking to folks who build products, one of my closest friends helps design parts for data centers for Google. And the only thing I have to say is Physna helps you find things without a bill of materials. And he's like, stop right there. I want to go more into that. Like, tell me if that's true, because as somebody who has written a vast number of bill of materials, understanding it's like the errors that can come into that, like the complexities that comes into designing it, but also it's like the limited ability to find what you're looking for within those constructs. That's something that becomes truly compelling. And that's why Physna exists. Physna exists to make true 3D search possible for manufacturers. And we do so to help you easily find, compare, and action 3D models. That's the North Star of what we're here to do. Physna understands every model by its unique object geometry, making it simple to not only find models, but also identify all of the applications of where those models can be used, and yields the following benefits for people, specifically around reducing complexity. when we think about software like communications, but also it's like through lines of throughput of like building one model over here in one department, designing another model over here in another department, and then field service applying another model into one. There's a lot of interconnected complexity that comes in with that Physna can help reduce. The second piece is around improving productivity. By being able to simplify the way that you view all of your 3D models, you can improve the productivity and design times for your manufacturers, for your engineers, and for your designers. This helps you bring products to market faster, which is really, really important in a speed where it's like we're running on prime speed, if you will, where it's like we're trying to figure out what are the different ways that we can cut through that. And then the last piece is it's like we help save money through advanced procurement. Like we understand, by understanding where a model where it can be used and where the supplier comes from, we're able to kind of go into detail with it and then really help you identify what are the best places that you can do within your own procurement models. And I'm going to go a little bit deeper into this, but I also promise you that I'm going to let Scott own the show for the latter half, because we all know that it's like people only want to hear from a marketer for so long, and hopefully I'm adding some value to it, but I want Scott to be able to really dive into the product in more detail. Understanding it's like that Phyzna's whole purpose and North Star is to make 3D search accessible. It all first off starts with establishing a clean way to visualize and understand where your 3D models are and where they are being used. So the simple takeaway from this particular slide is that Physna is able to find and action all of your 3D models across your established systems of record into one easy to use interfaces that helps you figure out what are the design complexities with each of those models, and then where can they apply and be used without actually going in and like remanipulating all of that data. The value in that goes back into accessibility, but now you're not only able to see what exists where, but you're also able to see where the various duplicates of those models are. When you talk to designers who are building products from scratch, they're coming in, they're designing new products, probably because they can't find the product they're looking for in the first place. So adding that level of visibility into the data set gives you one way to reduce that redundancy, but also helps you easily start to visualize the search and compare functions that make the product so powerful, which leads you into the core value of what we do, which is improving design and manufacturing productivity. By being able to search for an object by its geometry, we can find the best part of the job without accessing complex CAD or PLM software. By comparing similar models and considering similar parts, you can view all the differences between models, compare cost, and find best fits and alternatives that keep supply chain moving. This is a downstream impact that we're exploring more and more. But what we've seen is, especially within the last couple of years, is that the odds of a manufacturer having inventory on hand they can use to design and develop something is relatively high, but they can't see it. And so being able to see where that inventory lives means that you can take that inventory and then apply it into a new space, which helps you use the inventory that you already have, which is something that's critically important for us today. In identifying parts by image, using 2D images to locate 3D models, and removing friction for field service. This also applies for things outside of field service, but when we think about it in a very real-world application, the ability to take a photo and then index that against all of your 3D models, seeing what part it is and what parts it's compatible with, become an easy way to help accelerate maintenance, reduce downtime, and keep the trains running on time. And then the final piece to that, which I've started to already touch on, is making that smarter procurement decisions. So by understanding models by geometry, we're able to see beyond, or we're able to give you the ability to see beyond the numbers, suppliers, and part applications to help you identify where existing applicable parts can be used and where they should be used. And so one of the chief examples, if you look at a bolt, it's like you can buy a bolt and call it part X, A, B, C, and have another bolt that's the exact same thing as part XYZ. They're functionally the exact same, but the way that they're stored within our systems of record call them out as something different. They're purchased from a different supplier, and therefore it could have variations in cost of what those things fit to. And so again, this level of optic and visibility is something that really helps you drive a lot of simplicity across our already complex data practices. And it's why Physna is here. And so I'm going to slow down the pace of which I talk. I know that I can talk a little bit fast. I also get really excited when I get to speak with people. It's having been in a work from home environment for the last 2 years. But I'm going to slow down the pace. And then I'm also going to turn over control of my screen to Scott so that he can walk you through the product in more detail too. So with that, Scott, I'll pass it over to you. And then after that, we can go into an active Q&A.
Awesome.
Okay?
Yeah, thanks, Bo. So hello, everyone. My name's Scott Shipley, and I'm part of our solution engineering team here at Physna. And I'm really excited to walk you through the Physna Enterprise solution. I think what you're going to see today is some super innovative technology that we would argue is the future in harnessing the full potential of your 3D data. So let's start with what is Physna. As Bo mentioned, Physna is a cloud-based AI software that breaks down the structure of 3D models for things like analysis, search, comparison, and classification. So how exactly do we do this? Well, we start by taking an existing 3D model or 3D models, and we apply machine learning and other advanced mathematics to make those models accessible, searchable, and ultimately actionable to a broader range of use cases, some of which Bo touched on. So Physna technology, it can significantly help reduce design hours from what we hear from other customers. Redesign, reuse of products is an important one. SKU reduction is another huge area. We also hear from customers around lowering procurement costs, and Bo just talked a little bit about that. But another area is really the aspect of being able to enable deep learning and provide insights across your 3D data. And honestly, there really isn't anything like it on the market that we've seen today. So where I like to open up and really illustrate what the technology looks like is let's focus on our consumer offering called things.com. So I'm going to go ahead and share out my screen, and we'll start here. All right. So it looks like everyone can see it okay. So what I'm going to do is I'm going to start here with a simple search. Now normally I could click in here and I could search for a bearing, but in this case, I'm going to click on this little button here. And what this lets me do is I can actually browse from a number of different places, and I have a 3D CAD model here, and I'm going to go ahead and open it up. And what's interesting is I'm doing this real time. So as you can see, across 8+ million objects with thousands of concurrent users, it was able to convert that file, find the actual bearing within the midst of all of that, and then also found a turbocharger. So I'm going to go ahead and I'm going to click on this turbocharger, and let's explore that a little bit more. So what's interesting is I can take this turbocharger and I can explode it apart. And what you'll see is actually the two bearings I searched for, it found the bearings. But if I draw your attention over here to the right, you can see the assembly list. And what's interesting is you don't actually see the bearing listed in any of that. And the reason for that is because within the turbocharger, there's actually this impeller axle. And so if I look at this impeller axle, you can clearly see the bearing right there. So the reason that I like to start here is because right off the bat, one, we're able to illustrate what Physna's technology is doing. It's taking a core 3D object and finding it buried inside another 3D object, which in this case was the impeller, which was then buried inside of another 3D object, which was the turbocharger. And it's able to do that extremely fast with no bill of materials, no parts list, no database lookups. And it was again based solely off of the geometric fingerprint that we created of that model. The other cool thing is that you can run this off a standard computer or a smartphone or smart device, and you don't need any kind of expensive CAD license to go along with it. So let's go ahead and I'll transition from things over to our actual enterprise product. So our enterprise solution, something that I should mention is it's a dedicated and isolated environment. So it has your data, your users, your models, and the core architecture, which was one of the questions John asked about, and we can have a separate conversation to really deep dive on that. But it's a SaaS-based service, right? So there's nothing that you have to install on a computer to make it work. It works through a browser, and it's infinitely scalable, just like your typical SaaS platforms. So now that I've transitioned over to the enterprise product, let's search for that same bearing. But this time I'm actually going to do it based off of a text search. So if I type in bearing and go ahead and search for that, you'll see that what Physna did was it brought back every part with bearing listed in the name. So let me show you another advanced feature, which we call part match. So if I click on this actions menu and select part match next to the bearing, I can actually go and it's going to do what I similarly showed you on things.com. So very quickly, it was able to find all of the different objects or assemblies that this bearing belongs in. So let's take a little bit closer look at the actual turbocharger. So just like in things, I can open this up. I have the ability to be able to expand and break it all apart. But one of the things that I'd like to show you is what we call our assembly tree. And so we can kind of go through that. So let me click on that. And very quickly, I can actually see all the different components that make up the turbocharger. And I'm going to focus on this specific bolt for the next use case. And I'm going to show you another advanced feature, which is pretty cool. So let's go ahead and open up this bolt. And you can see I have the 3D model here. And I'm going to click over here on actions, and I'm going to do what's called a compare. And so with the compare, what's going on is Physna is actually showing you the two different models. So you can see I have the bolt here in relative size to the turbocharger. But something that's really cool is that we can actually ask Physna some questions about the bolt. And so one of the questions I want to ask it is, where is this bolt used across this turbocharger? So if I come down here and select the intersection of the turbocharger, you can very quickly see that Physna highlighted all the different areas. We have this ability to adjust the opacity so it's easier to see. You can see all of the different bolts that are used within that environment. So it's another great feature that customers have told us that they love, because they're able to quickly locate a part no matter where it's used within an assembly. All right, so let's talk through another really cool feature. So imagine that you're a maintenance worker and you're working in a plant and a machine has broken and you've got the call that you need to go get it up and running. So you go out to the machine, you identify the broken part, but the part's too worn or there's no part number on it. And so what are you going to do? Well, hopefully you have the knowledge, is what we kind of hear from customers that are in this scenario, where they know what the part might be because they've seen it before, or maybe they have a colleague that they can ask. But what if you could just take a picture of that part, give it to Physna, and let's see what Physna can find. So we're going to go through and do that right now. So I have this ability to come down here, and we have this classify image option. So we're going to go ahead and click on that. Now, I just happen to have a picture of this broken part. So I'm going to click browse, and the part had oil on it. So we put it into a bag and we put it on a table that has a dark background. Now, full disclosure, I'm also trying to do this because typically for machine learning algorithms, giving it something difficult like this makes it sometimes weird results. And so I want to just show you the power of what Physna can do. So I'm going to go ahead and click and open this. And here we go. So Physna has actually come back. It shows me the part, and it's given me a list of different components that it thinks could be this part or related to the part. So you can see the very first one here. I think I want to focus on that. So let's go ahead, and I'm going to hover over and I'm going to open this CAD model. So here you can see the model. Now it's interesting, it has grooves on it and my picture was flat, but if I turn it over, you can very easily see that this part is actually a standard common part that you can buy. It's called a cylinder stopper, and you can see that I was able to find the exact part that I was looking for. So now that we've opened it up, and I have confirmed that this is the exact part that I'm looking for, let's go and use a feature that we store in metadata where I can look at our inventory that could be pulled from a system like an ERP system or other environment. So if I click over here, I can look at the inventory and very quickly I can see, okay, the stock location for this in this case is R54. But unfortunately, and this is bad news for me because the maintenance, the machine is down in the plant, right? Every minute that it's down is costing money, and I can see that the quantity is 0. So let's look at some other areas because all hope is not lost. There's another feature that we call match. So let me switch over to that. So I'm going to take the same part that I have, and I am going to come over here and run a match report. Now, what's going to happen is Physna is going to search across all of its environment, look at all the different models, and it's going to come back and show me with a level of confidence, is this a match to what I'm looking for? So very quickly, you can actually see that it found a number of different parts that are 100% matches. This is also a great feature that customers like in order to be able to find out where could we have parts that are duplicates, kind of the scenario that Bo showed towards the end with part ABC and XYZ. But in this case, I'm going to show you another really cool feature. And what we're going to do is I'm actually going to pick this part and I'm going to do a compare and kind of look at this part, compare this part to the one that I was looking at. And so we have this different view, so I can actually look at these two things. And very quickly, I have, you know, the model on the left and the model on the right, and Physna is highlighting the differences for me between the two parts. So let's go ahead and I'm going to click on model details, and I'm just going to open this one, and we're going to go into kind of looking at some more in depth around the metadata as well as how we can break down an assembly tree. So you remember that I don't have any of this specific part in inventory. So we're going to use Physna to do something a little bit different, and I'm going to ask it to show me a breakdown of these different pieces. So let's go ahead and click on the assembly tree. And for the cylinder stopper, you can see that there's 3 main parts. So it's got a filter, it's got the housing, and it's got the cylinder stopper. So I'm going to go ahead and actually open up these into a new window here. And let's go ahead and look at this first one. So you can see for the filter, let's look at the metadata on this. And good news, I actually have a quantity of 20 of these. I can see the location where it is. So let's go ahead and come up here and open the next part that I looked at, which was the assembly. So let's open the metadata for that. And you can see that I have a quantity of 3. And then finally, let's look at the cylinder stopper and look at the metadata for that. So you can see that I have a quantity of 34. So very quickly, I can actually go and get all 3 of these components and know based off of the matching and comparison that we did through Physna, that we can actually use these parts to be able to get our machine back up and running. All right, so let's look at another feature. And this is kind of an interesting use case because one of our customers came to us and said, hey, we have a scenario where we have millions of parts and we have this entire team of people trying to go through and look at all the metadata and look at the geometry and classify what these different parts, put them into different buckets. And so they were like, would it be possible for Physna to be able to do this for us? And so our design team looked at it, and because of how we do agile development, it took our team between 6 and 8 weeks, and we actually rolled out this feature. And so it's a pretty cool feature that I want to show you. So in this use case, we took about 1,600 parts from, think of standard parts that you could find at any big box like hardware store. And we kind of threw it at Physna and said, hey, what can you do with these parts? And so the first thing it did is it created all of these different groupings of parts that it thought were similar to itself. So we see these different groupings, and over here on this side, it actually has different classifications that has created, so I can look at these different things. So let's go ahead and maybe we'll pick on self-leveling legs. So we'll have the self-leveling legs come up, and there's this other feature right here where I have all of these different groups of unclassified models. And I want Physna to start giving me predictions on, hey, based off of what you've seen so far from this classification, what can you tell me based off of what it's trying to do? So Physna is going to go and it's going to run through all of those different unclassified models. And it comes back with, hey, here's a list of models that we think align to these self-leveling legs. And so sure enough, I can look at it and I could select all of these and I can go ahead and classify it, which is pretty cool. Let's come over here to a different use case, which is hand wheels. So what I'll point out about the hand wheels is you can see some of these have 4 spokes, some of them have 2. The thickness of the handle and the wheel is different levels. And so I can come over here and click on predictions. So Physna is going to run through, and it was interesting because it came back and said, hey, I can't find any of those. But if you try lowering your confidence slider, we give you the ability to be able to go and run through another search. So I'll adjust it down and see what Physna comes back with. So it'll take just a second. It'll run through those thousands of models and it will come back. And sure enough, it's found different wheels that it said, hey, I think this is what you should, should fall into the classification of a hand wheel. So let me just stop there and let's kind of recap what we saw. So based off the 3D models, geometric fingerprint that Physna creates, we call it the Physna DNA or the PNA. Physna was able to find a bearing located within an impeller assembly, which was located within a turbocharger. We were able to compare 3D parts to the larger assembly and find all the locations where that 3D part existed. We were able to use our photo to 3D functionality, and using metadata and the assembly tree information, we were able to find the exact matching parts to replace the broken part in our machine maintenance scenario. Then we saw how Physna can find duplicate parts as well as similar parts, and how we can use that technology to search for existing 3D models, or for like use cases where we want to look at reuse for engineering and design teams, all the way down to SKU reduction, which is another big area that we hear from a lot of customers. Finally, we kind of showed you how Physna can take huge amounts of parts and data from models and throw them into groups and buckets and see how Physna can be used to help really classify. I was working with a large industrial equipment manufacturer a couple of weeks ago, and they were kind of walking me through, they had a PLM system, and when they were showing me what they were using, I noticed that several of the fields were highlighted in red after the part classification, and it said, do not trust the data. So I asked the customer, I was like, what's that about? And he was like, well, over the years of us entering all of this information, the data was just wrong based off of what people, had manually put in. And so they're actually using this specific technology around classification to help them kind of sanitize their data and make it clean. So I'll stop there and we'll go ahead and jump back to Bo, and we can open it up for Q&A.
Thank you for that. Really appreciate it. And so I'm actually going to go ahead. I'll pull up this. We're going to go into, we're at 33 minutes after the hour. So we've got about 10 or 15 minutes or so that we can reserve for Q&A for the team. And so what I'd say is if you have any questions that popped up from what you see, it's like, feel free to ask. You can go ahead and unmute. The only thing I will say is if you aren't speaking, please stay on mute so that we can be respectful of the folks that are around. And so who would like to lead off with any questions that you might have? Michael, go for it.
Thanks, Bo. Appreciate the introduction. It was really helpful. And Scott, my question is file types. What type of file types does Physna handle?
So there's a number of standard file types that we, pretty much all of your standard CAD file types, but Michael, we'll send you an exact list. We actually have that broken down so that you can have a copy of that.
Terrific. Thank you. It's helpful.
Who's next?
Michael broke the seal with it. So there shouldn't be any fear.
Ask a quick question.
Yeah.
Sure. Hi. With the actual the integration with the parts themselves, right? What is the expected time cost for trying to actually get the initial modeling so it's uploaded and put on the server?
Yeah, so I'll take that. So what that typically looks like, again, it depends on how many models we're talking about, right? Like 1,000,000 models is probably going to take a little bit longer than a few thousand, but our key way that we want to kind of load those models is through the Physna base connector. And so that allows us to be able to connect into a PLM, and you can kind of walk through like synchronizing different information. But the ingestion process is relatively fast, but we usually say between 2 and 3 days from the time it ingests all the data and then runs through all of the analysis. But if it's just a few files, like I'll give you an example. I was working with our engineering team on another one, and we were just testing like 35 models, and it only took like maybe 4 minutes to load them and kind of run through everything that it needed to. So it can be really fast, but it also, depending on the size, can take a little bit longer.
Okay, and just kind of a follow-up question to that, if that's okay.
Yeah.
So how's the adherence been for current pilots or traction that you have? Is there a high level of adherence? Because obviously the models need to be uploaded, or else there's no data on it.
Yeah. So if I understand your question correctly, you mean like adherence in terms of like someone goes through a pilot and they look at it and then there's like, okay, what do we see, and move forward with it?
So I mean more like I've actually uploaded the models, right? The whole question, this is a great system contingent on the adherence of the end user, right? If they don't use it, then it doesn't serve its purpose. And that's always the issue with anything to do with data or modeling. You always have the question of if the end user is actually using it, it's a wonderful tool. But if they're not, then for whatever reasons.
So I would say, from a standpoint of getting people to adopt, one of the easiest or least barrier of entry, if you will, is probably through like the engineering and design team. So we'll often work with engineering managers, understand what the pain points are from that perspective, and then kind of move forward. I see Bo raising his hand, so I'll let him jump in too.
Yeah, I'll also add a little bit of that. And I think, Yeshua, you asked an awesome question in that sense. And I think the one thing that oftentimes comes up, and this might be part of that question, is how automatic is it? That's one thing that often comes to mind. And whenever you start talking about language like AI or machine learning, people would automatically think it's a magic trick of what it does. What's not discussed in that is, to your point, the investment that comes from when people are getting systems set up and teaching systems to learn over time. Machine learning is just that, it's learning. It's just doesn't know how to do it. It's like it gets better and well reversed over time. So the more that you're engaging with the system, the more that you're using the system, the smarter the recommendations are going to come back, the easier the classifications are going to be as it grows. And so I'm not going to come back and say, if you automatically sign a contract with Physna, we automatically make things simple and easy. It's like we have teams that help make sure that those models are loaded properly and we get everything like learning on the right track. But your point's 100% spot on. It's like the more that you use the system, the smarter it gets and the better it gets for your business and use cases.
The other thing that I would add to what Bo said is understanding the value stream, right? So when you can map out like what are the pain points that your specific business is dealing with and you're trying to solve, because that does vary from customer to customer. When you can align solving some of those key business challenges, it helps with the adoption for sure.
Awesome, thank you.
Mm-hmm.
Yes, Janine, go ahead. Thank you for raising your hand.
Hi there. If I've got 4 instances of Windchill, for example, at one location, do you have to load 4 different versions of the tool, or how does someone execute use of this across 4 instances within one company?
Yeah, that's an excellent question. So no, you don't have to implement 4 instances. So we have the capability with that connector where you can actually go in and choose, here's the data that I want to synchronize. How often do I want to synchronize it? It's probably a much deeper dive conversation that we can have around that, but you don't have to have 4 separate instances. You can actually have all of that data land, you know, in a centralized Physna environment for your company.
Okay, and then if for the ongoing, you're going to do this one-time cleanup activity and help them group parts and so forth, but then on an ongoing basis to minimize duplication of parts, do they keep the software? How does that work on a maintenance basis?
Yes. So if you think about it, like what Bo said, the more that you use it, the smarter it gets. And so some of my peers that are on here is interesting. We had a use case where we had a customer that we had built out some auto tag or smart tags that we have for products, and we had a customer actually load data into that environment where we had done some auto tagging for some other work, and it automatically found, it was like, hey, I found these parts that, you know, another group within your company had already classified, right? So to that point, the more that you train it, the smarter it gets in terms of like the classification, and the more data that you send at it just makes it that much easier. So I would definitely say, while it helps with the initial use case, there's definitely an ongoing benefit as well.
Okay, thank you.
Mm-hmm.
Awesome. Any other questions or comments? Going once. Matthew, go for it.
Yeah, I was wondering what kind of application. Like, it looks like this is all industrial based. Like, hey, you got manufacturing, machine tools, whatever. But you can take pictures and then match them. How much are you guys looking at a business scenario of just ingesting real world, like outside data, like not curated data, but just like I'm classifying cars and planes and trucks and these kinds of things, and then seeing how parts all relate in that fashion.
I'll let you take that one. That's an interesting use case.
I have one answer to that question, Scott. I was actually going to toss it to you first. I wanted to tackle it. I'll go ahead. And so, Matthew, if I'm hearing you correctly, it's like, what are we doing as a company that's going outside of work, like individual, like corporate data sets, to just indexing everything else that you see? Is that correct?
Right. So if you're doing like, you know, autonomous driving or something like that, and you want to see all these different items out there in the world and classify them and you know, put some behavior to them, like a person walks like this, a plane flies like this, it's got these vectors over time, we can do a prediction. But there's a whole bunch of scenarios that I think you kind of get the idea.
Yeah. The guidance I would give to that question is all of those efforts, when it comes to looking outside of the corporate system, all of that's going to fall into the realm of thanks, which is what Scott originally gave you that image of, because that's area where it's like the information that is gathered is freely shared and open. With Physna, the core focus is around the organization of 3D models within that corporate environment. And the reason for that is corporate IP is everything to companies. And it's one of those things that it's like, if you design something, it's like you want that design as your design, unless you're moving into an open source design methodology, which you could be, but that's where things really comes into play. And so for us on our side, our core focus today is specific around the data sets that companies already have and already build, and making that exponentially more valuable to folks, to that company, that is. It's a good question. It's a great question. Thank you for asking it. Okay, we've got 2 minutes left. Any final questions? Or I can give you 2 minutes of your time back, and you guys can all have a great afternoon, evening, or if you're on the other side of the world, go to bed. Awesome. Guys, thank you all for joining us like during this 44-minute overview of Physna and the overview demo. We hope that you found it valuable. I know for any of you, it's like, again, my name is Bo Mangles. You have my email address at this point. It's just bo@physna. If you have any questions at all, comments, feedback, anything of what you would like to see in future sessions like this, don't hesitate to reach out and say something. And thank you for spending the time. We look forward to working with y'all in the future. Have a great rest of the day, y'all. All right. Bye.